Hi, I'm Dennis Hurst with Saltworks Security. Thank you so much for joining our demo today. Today, I'm going to be showing you SaltMiner, our application security posture management solution. First, what I'd like to do is start out and talk about what's the problem we're solving. If you go back in our industry in the application security space, even 20 years ago, really there were very few solutions to do scanning. So we had Web Inspect, we had AppScan, there were some others that came out around that time. But it was pretty easy to manage back then. There weren't too many scanners. So as application security engineers, it was okay. We could manage that. But then what happened is we kind of started entering a world where new tools began to enter the market. And they were scanning not only different vendors doing the same thing, but different vendors doing net new things, new kinds of scanning as we found new vulnerabilities. So the landscape really changed. What also happened was people had lots and lots of data that they needed to manage from all of these solutions, and it was very confusing. It was very hard, as you can imagine, in a large company that has a massive array of solutions to say, what should a developer fix today? What's the most important thing they can do? So ultimately, what we're trying to do is help solve that problem. Some of the business problems that really came out as a result of that were really some significant losses of revenue. If you think about it, the first big problem we had was a loss of revenue due to those development delays. So first problem is developers might waste time fixing the wrong issue or a low priority issue or something that wasn't exploitable, something that, chasing sort of a red herring, if you will. They also waste time working with multiple systems. We've spent the last 2 decades implementing Agile and DevOps, and a really large part of that is to have a single system where developers can work, they can manage their work, they can release on an iterative cycle. And then as security engineers, we come along and say, oh, by the way, go look at these 5 other systems for your work, which really just it wastes time. We know that from Agile and DevOps experiences over the last 2 decades. And that really led to kind of a third big cost and inefficiency, which is where security was causing friction and inefficiencies in development. As security engineers, we were telling people what the problems were, and we're telling the developers what needed to be fixed, but we weren't doing it efficiently. So there was lots of meetings, there were emails and PDFs and all these kinds of things where security engineers were really trying to do their best to communicate risk, and developers were trying to do their best to fix problems and get their software out. But in the mix of that, we had friction. Anytime there's friction, there's inefficiency. Anytime there's inefficiency, it costs money because you have to pay all these people's salaries. Next big thing we had was an increase in risk. So with no single source of truth and no really good way to say what's the business risk of a vulnerability, not just its severity, not is it critical, high, medium, or low, which is important to know, but what's the actual risk to the business? If somebody exploits this, how bad is it for us? What's the true risk? Or how probable is it that they could exploit it? Where is this system? It was really challenging to come up with that when we had all these different sources. Next big problem was an increase in cost due to that ability to report KPIs and metrics to executive management. Executives need the ability to see clearly what's going on in the business, manage it, know where to deploy capital. So if they need to fix problems, they can, get money or people or technology or whatever it is. But if we can't communicate vulnerabilities well or the state of our AppSec program, your executives are really kind of blind to the problems. So it also led to a lot of cost inefficiencies with respect to audit and compliance. A lot of companies are subject to audits. Even if you're just doing simple things like credit card processing, you're going to be subject to potentially PCI audits. And the more time that takes, the slower it is, the more cost there is to that. So it becomes a real challenge of how to do that. And finally, we ask a lot of security engineers to go manually try to get these reports together. So they might spend days or weeks every month just going out and trying to pull information together. So it was unreliable. It was a waste of their time. And these are smart people, highly valuable engineers. We really don't want to be wasting their time doing that if we can help it. So all of these things were costing money, increasing risk. It was just a real challenge. So we looked at how do we fix this? And these were problems that we were facing with our customers. So what we did is we came up with a solution we call SaltMiner. We're in about our 5th year of this product now. So we've been doing this for a while, really based on our experience as a consulting company, helping people solve their AppSec problems is really where the solution came from. We really didn't set out to be a software company. We were solving problems for customers, and a solution was developed, and we've now rolled that out as a full production software package. But it was really driven on customer needs and we really were our first customers. So it's been a really great solution for us. So the idea behind SaltMiner is pretty straightforward. We're taking information from lots of data sources, and I'll show you the different data sources later on in the demonstration. But we can take a lot of different information that's application security related. Now, that could be your traditional static scanners, dynamic scanners, kind of the things we all know and love. It could go out to things like Wiz, which is doing things like container scanning and looking at secret scanning and looking at a lot of different things in your cloud environment, because that definition of what is application security has really been stretched. Especially if you think about it, we now deploy applications as code. So less and less do we go install something on a server. More and more we create a container, like a Docker container. From the developers, we run that container through test and then we put it in production. So really, we are taking something the developer did and sticking it in production. So we really have to expand our definition of what is application security, really just because of the nature of the way we deploy code anymore. So we're aggregating data from all of these data sources. That's the first big thing we obviously have to do. Next big thing we took on was to normalize the data. And this has two facets. The first is simply normalizing the data into a common schema. We realize that a lot of what we're doing is reporting and metrics and visualizations and things like that. So we wanted to pull the data into a standard format. And instead of creating our own, we went with the Elastic Common Schema, or the ECS format. Our underlying technology is built on Elastic, and I'll talk about that more in a bit. We feel like it's just a great solution and partnership that we've developed. So we chose their standard. It also holds us to a good standard of making sure that we weren't making decisions. We were trying to do something that was really an industry standard. Next big thing we did in normalizing was to normalize the meaning of the data. What I mean by that is one vulnerability scanner may call something critical. The next one may call it high, but that may have the same meaning. It may be this is the bad thing that really gets you owned. And it's just a question of definition. So as we do it, we try to apply to the NIST standards to say we use critical, high, mediums, lows, and we do that across all of our data elements. We want to make sure that we are putting our data in a format that's usable, not only by us, but everybody else. We want it to be very open, and we have a real commitment to open standards, but also that the meanings comply to open and accepted standards, so that as a security professional, a developer, you understand what it means when we say this is a high, that's conforming to a NIST standard and it has a definition that's not just what we thought. Third big thing we do is around enriching the data with business context. And this is a big one. So what this means is we can go out and integrate with an application inventory. So things like a ServiceNow, a spreadsheet, a database, whatever you have that has a list of your applications along with their business attributes. So things like what tier level it is. So is it a tier 1, it's your crown jewels, really got to protect that. Is it tier 2, tier 3, tier 4, maybe a public marketing site that you need to protect, but not as much. Is it internet facing? Is it holding data that's highly risky? Different kind of things like that. What sort of compliance regulations does it have? It could be also who are the business owners, who's the technical owner. Any of that business metadata that you really want to know so that you can start asking interesting questions of your data. So that's the third big thing we do. Based on that, we can then do the fourth thing, which is apply a risk model, and it's actually a risk and compliance model, so that we can score those vulnerabilities, not just based on severity, again, critical, high, medium, low, which is important, but we can also say, based on the attributes of the application, is it exposed, what tier level it is, things like that, we can say, what's the risk to the business of this vulnerability? And we're going to get into that more in just a second. So once we've done that, the data then is in a format that we can start to use it. And we can make that available to lots of users that need this information. Going back to our business problems we had, we can communicate with developers to tell them what they should fix first. We can communicate with executives to show them the state of the application security program. We can communicate with compliance and audits so that they can do their audits more efficiently. And obviously, we're going to be a major platform for the security engineers who really need to understand what's going on inside their program. So that's kind of the architectural high-level overview of SaltMiner. So let me jump in and first kind of jump into one of our primary views and give you a demonstration of what does it look like if I'm a security user jumping in. I really just want to research vulnerabilities and how can I use this. First thing that happens when I go to log in is I'm going to be presented with a list of spaces. What spaces are is simply a collection of dashboards, visualizations, reports. It's the sections that we'd use, for example, for different audiences. So we typically would have, one for developers, one for security users. We call that our vulnerability view. We might have one for risk and compliance, executives, just different views. And it really is a container, if you will, of dashboards and visualizations and reporting mechanisms for a particular audience. And we can restrict down who sees those. So in this case, I'm logged in as a security user. I kind of see everything. So I'm going to jump into the vulnerability view. And again, this is really the one that a security engineer, an auditor might spend most of their time in. So from here, what we've got is the ability to look at the data, and we're looking at this data from a vulnerability perspective. And again, we're going to talk about risk in just a second. But from here, we're looking at it from a vulnerability perspective. And we've got, right out of the bat, we've got a list of fields at the top. This is customizable. We customize that based on the application inventory you've got. And this is really where people spend most of their time, where they may want to know, okay, well, what are the vulnerabilities from my finance team? And so they can focus down on just finance vulnerabilities, or they could clear that out and zoom back out and look at everything. They could look at them by application name if they wanted to. They could look at them by compliance standards. And in this case, for example, I've got GDPR and I've got PCI. So I've got, two common standards there. We can completely customize this based on the customer's needs. You can do it yourself as well. Again, we've built this technology on top of Elastic and Kibana and then extended it, similar to the way that Elastic extends for their SIEM and other tools. We really followed that same model. So very easy if you've used Elastic, if you've used Kibana, it's going to be super simple for you to customize any of these dashboards. And we typically do that as well just during the rollout period. So when I start out, I've got, my various vulnerabilities, and I can come in and start to look at, well, where are the real problems that I've got here that I need to go look at? So for example, I'm going to go look at the most common vulnerability. And now I've filtered down to those. Those are just informational. So I might go, oh, okay, not really what I'm worried about. Let's go look at high vulnerabilities. So I click on high, and now I can see of my high vulnerabilities, here's the most common thing. And I could filter down to just that, again, just by clicking on it. So we can navigate through our data and really ask questions. And by doing that, what I've done down below is I'm looking to see for that high vulnerability, for that most common high vulnerability, which applications have it and where could I go fix it? So if we notice Spring Boot, for example, has 6,386 of these. So that would give me an indication that something's going on in there. Maybe there's a repeated code or something like that. So I could pretty quickly go find those. I can also then go navigate down through the data as well and look at what are counts of vulnerabilities, again, by severity by applications. I can do it by versions. We can break this down as low as you would want. We could go at a higher level by business unit, for example. Again, very easy to customize these. We can come in and look at when were vulnerabilities discovered that are still open. So I want to know, and this is a common question, is what's the old stuff I've got to deal with? What are my old vulnerabilities? So I can go in and limit the timeline. And if you'll notice up in the upper right-hand corner, I've just filtered it down to everything that was opened or found from October of 2015 till May of this year. So things that are a little bit older, we could change that with this little slider. And it's going to show me then how many vulnerabilities in my dashboard are just from that time. I can also look at the count of scans. So I can see how often am I scanning. This becomes very helpful if you set policies, for example, that say we scan all applications every month. And you want to automate something to say if an application doesn't get scanned every month, let's fire an alert and let the developers know, go see what's going on and fix that problem. We can also do things like look at technical debt over time. So how many vulnerabilities were open at any given point in time. We also track this information for tools that don't support histories. Some things we get a scan and it says there's a vulnerability. Doesn't really tell you when it was first found. It's just a snapshot in time. A lot of the things that we'd see, for example, in Kali are going to give us that. So what we do is we track that for them. So the first time we see that vulnerability, we track it. And then when we no longer see it from that scanner, we know that it was closed. So we can track the technical debt of when did we see something? How long was it open? How long did it take to close it? And then finally, when was it removed? So we can look at change over time. And this really helps with looking at the maturity of a program or the maturity of your AppSec program. Now, in this case, we're scanning a bunch of open source libraries. So these are just things we've gone and downloaded off the internet. We have very little control over them. other than we can just scan them because they're open source. So we do see change over time in our demo data, but our technical debt has not shrunk as much as we would certainly like to from the open source community. And then once I've gone all the way down and I've looked at the vulnerabilities, I can go down and look at the actual individual vulnerabilities that make up this data set. I can export this out to a spreadsheet. We also then can link you back to the original source where the vulnerability was found. This becomes very helpful. A lot of times a developer can look at this and say, oh, I know what this problem is. They can jump in, they can fix it. Great. That's the way to go. Other times, though, they need to go look at the original tool. They need to look at a stack trace. They need to look at an HTTP request and response. They really need to dig into the details. So we don't try to replace those solutions. Our vision is that we want to make all of those solutions you've invested in as valuable as possible and as easy to use as possible. So what we're doing is giving you a link back to those solutions so that you get the value from them. You can see stack traces and requests and responses and all of the things that all of these tools do so well, and that's why we buy them. We want to link back to those and not try to replace them. We're trying to be something that makes them more powerful, more user friendly. So we've got that data as well. And then if you really want to dig in, you can pop open and look at all of the data that's coming across, and there's just pages and pages of information. So we could add any of this to a visualization. So if it's something that you want to use in a report or as a filter, easy to do that. It takes minutes to do that. So this is the most common view we would start out with. And obviously, as we work with customers, we really start tuning what you're going to see here. We start changing it to fit your needs. And it's something that can grow with you over time. Out of the box, there's huge value, but over time, it can grow and mature. And you can customize that, or we can certainly help you with that. So let's talk about architecture for a minute. We built SaltMiner on Elasticsearch, Nginx, very industry, very open standards. The reason we did that is we had some specific needs that we wanted to address. So the first one was it needed to be customizable. Every customer that we worked with, there were common things. They were running scans. It was application security, but they all had special things that were unique to their industry. So oil companies are different than finance companies, which are different than contractors for the government. They all have needs that are based on their business. So we realized that customizability for visualizations, for dashboards, for reporting was huge. So it had to be highly extendable. We also had to make it extendable with respect to pushing the data into things like Jira, ServiceNow, these other systems that developers want access to. If we go back to our user story around developers and what's costing us money, security not being a part of the developer ecosystem and that friction that we talked about originally, this is really addressing that. So if we can take vulnerabilities from multiple systems, push that into your ticket tracking systems, your all the systems that you're using that need the data, there's power there, and we can make application security more efficient. We can reduce friction. We can save cost. We also knew that some users were going to want to pull the data out of our system and into some external systems. So we like the fact that we used Elasticsearch, we use their REST API extensively, we expose that so that it's very easy to query it. It's a very simple REST API, heavily documented. It's a very powerful API. We document our schema completely. Again, trying to be really open in the way that we created the solution for engineers to use it in the ways that they need to do it. And then finally, there was scale. Scale was a huge one for us. We realized some of our early customers that had thousands of users that we had to have a system that scaled on a massive level. So again, we like the approach that Elastic uses when they deploy products, and we really extended that model. So we use Elasticsearch, we use Kibana as our reporting engine, we extend that. Again, very similar to the way that Elastic is done for their solutions, and then we put our visualizations or our GUI beside that. But from a user perspective, it's a transparent experience, but you get the scale of that very industrial strength visualization and search engine with the features you need in an application security platform. So that was a big one. So that's the architecture of SaltMiner. Next, let's take a look at the developer view. So we talked about some of those integrations, for example. So let's look at what a developer sees and how we can use the same technology for developers. So when I log into the developer view, you're going to notice it looks pretty similar. And that was on purpose. We try to keep the general look and feel consistent, but then we customize it to be what the user that's using the system needs to have. So for example, we've still got the ability to click on vulnerabilities and filter down. So at this point, we're pretty similar to the other views. One thing I would note is we can also restrict what access a user has. So typically when a developer logs in, they wouldn't see everything. What they would see is just the applications that they're assigned to. And we can synchronize that from various sources. But the idea being there, if I'm, the engineer that works on the accounting system, which this is an open source package that's out there, that's all I would see when I logged in. So I don't even have to go filter. I'm just going to log in, see my applications, and be done. And then I could very quickly go, oh, well, let's go look at critical vulnerabilities just in my applications. So the idea being we can really focus down on what needs to happen as a developer. We then all have the ability to show data in different structures. So for example, one of the things I like the most, and if we imagine a developer, we've probably have already pushed the tickets into their Jira system, so it's in their backlog. But if I'm a developer, I want to come in and say, well, what could I do today that would make the most impact to my backlog? What can I do that adds the most value, reduces risk the most? So I can come out in and we'll give them views, for example, to show where is the vulnerability coming from. So if I'm the developer of this application, I very quickly noticed that this Apex charts.js file has 601 criticals. That's probably something that I should focus on. So I could very quickly see, let's just go look at that one file. And then I come down and look, and we see, well, what kind of vulnerability is it? And if we notice, it's this same vulnerability just over and over again. Well, there's a good chance in that file, there's a function, there's some very limited place that has this problem. The developer can probably fix it super quick. So very quickly, I could knock out, if we look at the counts, potentially 601 critical issues. So there, it's not just that our data is in their backlog, which is good. We want to be there, but we may have put hundreds of things in their backlog. What we're going to give them the ability to do then is go in and focus and say, well, if I fix these few things, can I actually fix a whole lot of issues from my backlog and really burn down my backlog? Again, get the release out the door faster. So the developer view is all about helping the developer explore their data, understand where they can fix things, because we're already going to be integrated into their development process through their Jira, their ADO, whatever their system is. But this is going to give them the ability to research more and plan their work better. Again, all around the goal of reducing risk, making that developer more efficient. Next, let's take a look at the risk and compliance view. So risk and compliance is a big deal in the security industry. We're very good at finding vulnerabilities and saying this is critical, that's high. And what we're really talking about there is severity. It's really what's the likelihood, or how easy is it, or how much risk does it, or how much severity does it expose? So if it's a SQL injection, that's huge because I can get straight to your database. So that's going to be a critical. But it doesn't really tell me what the business risk is. So what we give the ability to do in SaltMiner is to put in a custom risk matrix, and typically they look something like what I've got on the screen, where there's something that says we take our severity, we multiply that by a factor for classification. So what kind of data is it? We multiply that by access. So does it have access at the internet? Is it isolated? Is it somewhere on a DMZ? Different things like that. And out of that, we come up with a score. So it's a quantitative score of how bad is that vulnerability and how much risk does that vulnerability represent to the company as a whole. So once we've got that, now we have quantitatively measured risk of the vulnerability. We then take the next step and say, okay, let's take that issue, that single finding, and let's roll that up to the asset. So in SaltMiner, when we say an asset, what we're talking about is the thing that was scanned. So if you do a static scan of an application, that scan, that collection of vulnerabilities based on that scan, that's an asset. It's the thing that you scanned. So it would really be that source code repo, for example. If it were a dynamic scan, the asset would be the website that you scan dynamically. So we roll the score up to the asset. So then we can say, how much risk do the vulnerabilities from this static scan or that open source scan or whatever it is represent to the business? And we can start to get a weight of, okay, how bad is this? We then take that and roll it up one level higher. And we call that the inventory level. And the inventory is this concept that when you're looking at application security, you're talking about systems. So you're talking about a web application that talks to a database that has source code. You've got dynamic scans of it. You've got open source scans of it. You've got all this data from different sources for a collection of systems that make up your actual system, your website, your booking system, whatever your online system is. So that's an inventory item. So we also then give you the ability to roll risk up to that level. So then we can look at different systems. We could look at your payroll system, your finance system, your booking online system, whatever your systems are, and say, across the board, where do we have the most risk exposed, and where should we really invest our time to go fix these problems? And it helps us go from a severity-based view of the world to a risk-based view of the world. So that's kind of huge. We do exactly the same thing with compliance, where we score things for compliance. Common things like you might say, our critical vulnerabilities have to be fixed in 30 days. Okay, that's a compliance failure, for example, if you don't do it. So we would then roll that failure up from the issue, which hadn't been fixed, to the asset because it's now failing, all the way up to that inventory item to say, hey, this application is out of compliance. And then we can give you details of why is it out of compliance. So that ability to take vulnerability ranking and translate that to your custom business risk, your custom business compliance is a huge thing that people need to bridge that gap from risk or severity to risk and compliance. So let's look at what that looks like. So when we get into the risk and compliance dashboard, what we've done here is, again, we've taken the vulnerabilities, we've scored them, and each of those vulnerabilities got a score, and then we rolled them up to the asset. In this case, an asset would be things like an application version. So we've got this Nextcloud and latest release, so that's an asset, or a project version, some people would call that, and it has a risk score. So we can say that this Nextcloud system, this latest release, represents the most risk to the company. And we can also search and view on it, which typically are things you want to be able to do. So for example, I can come up here and say, oh, look, there it is. This Nextcloud server, this system represents 27.23% of our risk as we've defined it. And I could click on that and filter down to just that application. Now it's going to show me that it's made up by two versions. So version 1.2.13. And also there's a release that's out there called the latest. So sometimes what we would see, maybe we see old versions, and it may be that you're just scanning something old that's not used anymore, needs to be retired, and that could remove risk. But it gives you an idea of, again, where is that risk coming from? We can also look at our vulnerabilities and say, well, how is that vulnerability relating to risk? So if I broaden back out a little bit, for example, I can tell you that key management, hard-coded encryption keys is by far in my world right now the biggest risk I've got. This also potentially would lead to training. So if we're going to pay money to have our developers trained and focus on something and spend time on it, this may be the thing we want to spend the most time on because we have the most of it. It's costing us the most risk. It's the place we want to focus. And then really all of our dashboards now are not severity based like we would typically would see, but they're risk based. So same information, simply looking at it from a risk perspective, not from a vulnerability perspective. And we can combine this data, obviously. We can score things and show things like where most of our risk coming from. We can put in different kinds of visualizations. Your typical issue, your word cloud, if it's a simpler way to do it. So that's a good one to do. And of course, just a nice tabular view that you can export out to Excel, whatever you want to use to work with the data. So this is our risk view, similar to the views we had before, but the underlying activity that's happening is quite different, where we're calculating that risk score, not just a severity from the scanning solutions. I mentioned before that we would talk about some of the integrations. This is our current list of integrations that we have. We are adding those constantly. Typically, the way that we add things to this list is we work with customers and prospects and finding out what they need and where the demand is, and we add them based on their need. We're very proud of the fact that we work with all of these vendors. Again, our goal is to make whatever solution you have look the best it can and give you the most value. So if you're a vendor working with us, we want to really make your solution look great because customers have paid for it and want to get the value from it. So this is our current list of integrations. We are adding things constantly. It takes us a couple of weeks to add an integration. So this list will continue to grow, and you can check our website for updates on that. If you've got questions about anything I've done, please feel free to email me. My email is dennis@saltworks.io. You're more than welcome to email me. You can also send an email to our support team if you've got questions, just support@saltworks.io. And our sales team would love to work with you if you've got more in-depth questions, would like to see a proof of concept. And that's, as you can imagine, sales@saltworks.io. Thank you again so much for your time today. I appreciate it. Hope you have a wonderful day.